My name is Craig Johnson. I'm a principal architect at Forward Networks, primarily a network engineer. So I'm curious, out of everyone here, would anyone here consider themselves a networking guy, network engineer, network architect, come from that world? We got one. Okay, awesome. So I want to talk a little bit about my experience and a little bit about how to do some of the more traditional networking tools and port them over to using an AWS environment. So a little bit about me. Most of my career has been on-prem. I spent many years at Cisco, a couple of startups. The idea being is most of the experience I have is on the on-prem side. So working on Cisco routers, logging in, configuring, doing all that sort of CLI-based work. So most of the network engineers you see are going to be CLI-based. Transitioning to networking in AWS has been a bit of a challenge for us, simply because it's not something that we're used to, and we're not used to doing APIs, things like that. We're used to SSHing into a router, doing show run commands, grabbing configurations, doing pings and trace routes, all of those sorts of things. So yeah, as you can see, I'm a CCIE. Most of my experience comes from that world, but I want to talk about how I've transitioned this over and how you can use some of the native tools inside AWS to help you troubleshoot your environment inside the cloud without having to, rely on other third-party tools to figure these sort of things. So these are all native tools that you would see inside AWS. So are the tools I have good enough today? I would say no. So what I want to talk about is how we can replicate the kind of things we do on-prem, like building a map of our network, building an entire environment, not just within a single account, a single region, across my entire estate. Can I troubleshoot my on-prem connectivity? Normally you have your on-prem guys, they kind of have that black box world, and when they hand off traffic, they don't see anything else, and vice versa. I don't think that's true. Can I handle multiple regions? Can I do troubleshooting within a particular VPC? Can I trace paths between there? A lot of people use flow logs for that. Is that a good idea? We'll see. And I want to talk about exactly how you can use this, not just from a troubleshooting and reactive standpoint, but to help you do this a little more proactively. So the tools I use to troubleshoot networking inside AWS are drastically different than what I would use if I was in a data center. What do I mean by that? So if I was in a data center and someone told me I was having a problem reaching a particular application, application A was having a hard time reaching application B, what would I do? They'd give me the IP address, okay, easy enough, and I would probably figure out where that IP address does some pings and trace routes, and then I would log in to whatever the closest router it happens to be. Maybe it's a top of rack switch, maybe it's my core router, maybe it's something else in between, depending if it's a firewall, load balancer, whatever it is. I can't really do that here. If someone says I'm having a hard time getting through this transit gateway, I can't log into the transit gateway and do a show run and do a show config and even do a ping and trace route from it because that doesn't exist for me. Are there equivalent tools? Maybe. There's no routing protocols here. So you got a little bit of BGP here, but if I was having an issue with path routing in a data center or across branches, almost every time on an on-prem environment, I have things like BGP, OSPF, ISIS to help me figure out, okay, here's my routing table. Here's where I learned that route from. It was learned from 10 hops away. Okay, I see the origin. I can figure that out. If you've ever done anything with path routing inside AWS, that kind of stuff doesn't exist. There's a teeny little bit of BGP between like a direct connect and the router, or maybe some static routing, but it's all basically static between them. So if I want to go from one place, I have to hop between places. So I've drastically reduced the amount of things I can use to troubleshoot in a cloud environment. That's not bad. In a lot of ways, it's simpler because I don't have to deal with all that protocol soup that I have to deal with in a data center. I don't need to worry about, MPLS and VXLAN and all those kind of overlays. It makes it a lot simpler, but the tools that I would use to troubleshoot to figure this out no longer exist. Like I said, lots and lots and lots of different places to check things. Like I said, if I log into a router, I can pull in the entire routing table in my data center, figure out where the origin is. If I look at a subnet routing table, I'm going to get just the few routes for whatever subnets are connected, maybe a route up to an internet gateway or NAT gateway or transit gateway, and then I have to go to that other place to check. It's even worse if I have shared resources across accounts, and then when I go to different regions, that problem gets even more difficult because then I'm flipping to a whole other different console to figure that out. So if someone tells me I've got an app in US East 1 and it's going to US West 2, and it has to go through my VPC route table to a transit gateway, peering to another transit gateway to the other side, that's a lot of different places to check and not a really good place to check them. It's all individual, and I don't have any way to use that. The stuff I use on-prem, it's sad to say, most of us on-prem engineers still use the tried and true ping and trace routes. They don't work very well at all inside AWS. In a lot of ways, that's a good reason. A lot of people consider these tools to be somewhat insecure because you can use this to figure out where everything is connected at. But at the same time, I don't have any ability to say, okay, where does my traffic actually stop at? If I am on an EC2 instance and I am trying to figure out why I can't reach this EC2 instance here to another region, it doesn't tell me exactly where it stops. It just says, well, the ping doesn't work, so where would I look to figure that out? I don't know. So understanding the traffic flow in an AWS environment is more critical than ever. A lot of people really ignore this idea because it's like, I can create these very simple constructs, I can create them quickly going, and if everything's static, that's fine, but if anything ever changes, I have no way to figure out where the traffic is, and I have a lot more things layered on top of it, because I've got things like security groups, I've got network ACLs, I've got gateway load balancers, I've got a lot more things that I would use to troubleshoot. A lot of people say, well, why not just turn on flow logs? So flow logs, if you're not aware, are a feature in VPC that are essentially like an old school packet sniffer. It will turn on all of the logging that tells me all of the traffic that is going everywhere that's inside of VPC. So it's like, why not just use that? Then I could see if the traffic is working or not. Well, like I said, it is an old school packet sniffer, and as someone who used to work for a network packet broker, that was a very lucrative business. And at the same time, flow logs are quite expensive to do because every bit of traffic inside your VPC gets logged, so you can see all sources, all destination, hit counts, everything like that. As you can imagine, massive amount of data to parse through to figure out where it is. And it also doesn't help me if the traffic isn't there yet. What I mean is if I have a new application coming online, or if I am just trying to figure out, hey, this is something new coming here, I need to figure out how this would work. Flow logs aren't going to help me because there's not actually a transaction going on. I actually have to synthetically create a transaction. Network guys typically don't have the same level of application access. We can see the endpoints, we see they were supposed to be, but we don't know what the application's really doing. So that level of coordination never really exists, especially if there is a network outage. So let's see what we can use inside AWS to figure this out. So it turns out there's actually quite a few tools, troubleshooting and analyzing tools inside AWS that will help you troubleshoot the networking experience and beyond troubleshooting, help you proactively figure out what's going on. So you've got Transit Gateway Network Manager, you've got Reachability Analyzer, you can even do infrastructure performance. A couple of new things, you can actually put flow monitors connected to EC2 instances if you were looking for actually like, what is the performance stats between two EC2 instances? You could actually get that to get synthetic transactions between them. But beyond that, if I just wanted to figure out and proactively and iteratively see where my troubleshooting, where the path between is, the tools there are available. And I want to show you some of those today and show you how I use those inside this environment to set up a more proactive monitoring system. So like I said, network engineers use the CLI. Is this the best thing? Probably not. But typically what we usually see is most people are more comfortable with that, and it's easier to troubleshoot because you're usually able to figure it out. So we'll use something similar inside AWS. We'll use the AWS CLI to figure all of this out. We'll get some of the API data first to figure this out, but we'll use the CLI to do this kind of troubleshooting. So the first thing we need to do, whenever you deal with a network engineer, they always have to have a map of the network. Simply because beyond just a few nodes, being able to visualize how traffic moves between different places is a real pain. Now, it's not as bad on AWS in a simple environment. Like if I deal with a single region, maybe a few VPCs, This VPC is going to be connected to the transit gateway. It's going to be connected to another VPC. That's really only a few hops. Multiply this by even just a couple of accounts, a couple of VPCs, and a couple of regions. This becomes a nightmare out of control. We learned this lesson a long time ago on-prem. And it's really kind of sad. I hardly see anybody else use the network mapping functionality that is built into AWS to do this. You can use this today for free. It doesn't cost you anything to create an easy map of your AWS environment that's not application-based, but that's network-based, that you can say, hey, here is how the path routing in my AWS environment works. So we're going to use AWS Network Manager to do that. So to get started to do that, the first thing you do is literally just create the global network. Now, global network is really important here. This is not a regional service. This works across no matter how many AWS regions you have, no matter how many accounts that you have. So when you have shared resources and you want to correlate these things together, very, very easy to do so. After I create this network, or create the global network, I'm going to create a site. Now this part is really cool because I can create on-prem sites that are connected to it. So this is not just dealing with my connectivity inside AWS. When I have VPN connections or direct connects, I can instantiate those as well and we'll automatically detect them and show them the connections. We're going to give it that network ID that I just created above. You can even put in physically where they're located at. If you want to show someone, your management, hey, here's what my network looks like, and here is, here we have in Wisconsin, and I have San Jose, I have Atlanta. You can show these on a nice, pretty map to show your entire infrastructure, what it looks like from end to end. Now I'm going to go ahead and create the device. Now, when I say device, I mean the on-prem device. This is the router, firewall, whatever it is that connects your hybrid infrastructure, connects your AWS environment to your on-prem. You're not configuring that thing, of course, but you're representing it there because you know where it is configured. Create the global network for that. Give it a site ID, you can have as many as you'd like. And then, of course, tell it that location. Now I'm going to create the link, create the network ID for the site. You can even put in bandwidth. So if I'm looking at, say, I need to know how much bandwidth is working on here because now I'm saying, okay, I've got the link here, but how do I know it's overloaded? I can pre-put in, hey, this particular direct connect is provisioned from my carrier for 1 gig up or 1 gig down, or this VPN connection is limited to 500 megabits. Whatever the characteristics happen to be, you can put that in here so you can easily say, hey, I'm overloading or underloading this particular link. So like I said, multiple account is very easy to do. Now, if you're using GovCloud, this is a little weird. You can't do multiple accounts. But multiple accounts super nice because most people I work with have, at least a dozen accounts. Some have hundreds. A couple I know have thousands, which is insane to me. So if you want to have multiple accounts that are set up that are shared resources with each other using a landing zone and people are sharing resources, super, super easy to do. Now, I can also update any of this information, tags, physical addresses. So you're not relying on just, hey, I have this infrastructure opening up my console and looking at kind of text blocks. Now I have a nice, pretty map to look all of this information. Okay, now at this, I'm going to register my transit gateway. So the key to this is the transit gateway manager. So almost everyone I know uses transit gateways. This also works with Cloud WAN if you're using that too. But transit gateways let me connect my VPCs together, let me connect regions together in a nice, centralized, scalable way. If you ever dealt with this before transit gateways were a thing, this was a complete pain because you had to have VPCs that were kind of broker points between them. So transit gateways are a blessing. Put that network ID, transit gateway, register that to that one. So any number of transit gateways you have, we're going to register that network. Associate all the links to that one. And then associate that gateway, all those on-prem routers into it. So this is a little easier to do with the GUI, I will admit. Now it's not as programmatic, but you can go in and click and do all of this. That is the easy button to do it. I'm just showing you the slightly more comprehensive way how you would pull all of this data. So once I've created all of this data, so all I did was create my network and register my transit gateways. It's a little hard to see from probably back here, but what it does is it automatically creates my transit gateways. It links them together. I didn't have to link them. This is based on the links that I already have within my environment. It shows me my links to all of my external connectivity. So I've got some VPNs over here. I've got some direct connects. I've got sites that are here. So now I have a map that shows you up and down how everything is connected And this is not based on a particular region. This is across my entire environment, so I see all of this data where it happens to be. Okay, I've got my map created. So now I know what my network looks like, and I can give this to people, and now I have a good basis to, one, troubleshoot if something goes wrong, but two, let me figure out if there is an issue, how I can make this a little more proactive. Same thing over here on the topology. You can see it in a slightly different view. I can actually show me all of my connections between individual regions. So if you wanted to broker out, each one of these green lines are a particular region. So if you wanted to break this down in a region viewpoint based on all of your external connectivity, you'd see that there too. Okay, that's in the entire global network. Most of the time where troubleshooting is gonna be within a region. So how would I figure out, let's say, back to the example I used before, I've got an instance in US West 2 and it needs to get to US East 1, it's not working. Most people would, do some trace routes and pings. Like I said, those probably don't work very well because most people have security groups that are gonna block all of those things, so you don't have any way to figure out. This is VPC Reachability Analyzer. It helps me do inter-region routing between different locations. So what I'm gonna do is I'm gonna start a route analysis. So a route analysis is going to use the native AWS reachability tools to say, synthetically, not actually putting real traffic on the network. That part is key. There's no real traffic going on here. This is simply looking at all of my configurations that I have and making sure that I have connectivity and make sure my things like my routes are configured right, to make sure I have connectivity between all of the points. Reference that global network ID, use the transit gateway that I'm coming from, and use the transit gateway that I'm going to. So I'm going between regions at this point. I can also do the return path. So that part's really important. Oftentimes what you'll see is somebody has one path going one way and it's asymmetric, going opposite the other way. Does that work for connectivity? Sure. Will that really mess up latency and all of my transactions? Absolutely, because now you have inconsistent path routing and you've got different latency coming and going. I can also use middle boxes. So middle boxes are what I mean if I have something in between, like if I put a third-party firewall in there. So let's say my security says, yeah, I know we got security groups, I know we've got all of that functionality there, but I need you to put Palo Alto firewall that brokers traffic. My security standards require it. We can use those. Now, of course, AWS is not polling those middle boxes. They exist on an EC2 instance somewhere. But if you make the assumption that that firewall knows what it's doing, it's going to say, okay, it hits the firewall. We're assuming the firewall passes the traffic, does whatever it needs to. Use that as an end-to-end path. So you're not breaking the path. You can still do end-to-end processing between any number of middle boxes. So now that we've done that, we're going to start that analysis with that ID. Now, the great thing about this is this can be run as often as needed. So what I like about this, if I'm using this for troubleshooting, this is great. I can use this to figure out, okay, does there a path and does it work or not? But at the same time, I can use this iteratively. I can create this as what's called an intent check and say, if I run this type of analysis every day, I can tell if anything has changed. I can use this for pre and post change any checks to make sure that the network is moving in and out correctly and the traffic is going right. Okay, so here's the results that I happen to have. So here I have good results. I have succeeded, I have my source IP, I've got my destination IP address. It tells me it's connected within this environment. So if it didn't work, it would tell me it didn't connect. It would say failed and say there's an issue with it. Now what would that mean? It tells me the middle box is in there too. Now you got a little visualization. I love this visualization because it tells you exactly where I start from the transit gateway and exactly how I pass through all of those environments. So it tells me I start from a particular VPN connection, so all the way from an edge connection, goes through my transit gateway route table, which is going to have some routes between places, goes to another transit gateway. That transit gateway has its own route table, goes to that VPN connection, makes it to its destination. And keep in mind, we're also doing the reverse path too. So now I can figure out what the reverse path is too. So now I can see that it is symmetric end to end. I have good verification. I have mathematical proof to say this traffic is working, whether it's traffic that's actually running or traffic that is going to be running. I can show this to people to say the network is not the problem. Bit of a joke among network engineers, the network is always the problem. Let's go a little deeper. So I did troubleshooting within an environment, and I showed you how to do troubleshooting, and I showed you how to do use that a little more proactively if you wanted to see if this ever changed. How would I actually do troubleshooting within a region? So this is probably a bit more common. I've got a couple of VPCs in a region. App A can't reach App A. They happen to be in the same region, but they're connected in different VPCs. There is some broker between them. There is some centralized inspection. How would I use this to check things like network ACLs? Those are 5-tuple stateless filtering that would block things. What about security groups? Those are going to be stateful, and those are going to be attached to every sort of instance to see what's going on. Like I said, you could use VPC flow logs to do this and see if where the traffic is dropping, but that is a massive amount of data, and it only helps me if the traffic is actually running in the environment. So this comes to my favorite tool, VPC Reachability Analyzer. So in VPC Reachability Analyzer, what I'm going to do is I'm going to set up a path within a region. It's called Create Network Insights Path. So I'm going to set up the source. Now the source can be lots of things. I can put it in an IP address, I can put it in an instance, I can put it in an attachment point, I can put it in a VPN, I can use all sorts of resources to do this. So normally you're probably going to put in an instance, so it's going to put in I dash whatever the instance is, but it could just be I don't have the instance yet, just show me what the subnet connection is. Put it in the destination, same idea. Tell me what protocol it is. So before I was just looking at connectivity. Now I'm going into L4 connections. Like maybe there's connectivity, but something is blocking my HTTPS connection because I've got a security group or something weird like that. So I'm going to say TCP, and I'm going to say I want to do via HTTPS. So when I connect that there, I'm going to say, let's start that analysis. Now this analysis is run on demand. So I get a good history to say, if I run the analysis yesterday, I can see what happened with that path. And if I run it again today, it's going to give me a history. Okay, yesterday it worked, today it didn't. So something must have changed within the environment because I have a good history to see what's going on. This is extremely valuable for network engineers because it's in a networking world, I can go back and see what config changed on a router. A router config is just a long flat text file. That of course doesn't exist here. This is all API data, but I can get a good history and say exactly what's going on. Now that I've created that path, I'm going to describe that path and I'm going to tell me, hey, tell me this path within my region, does it work or does it not work? Point in time analysis, now I can set these predefined paths. This is where this becomes really interesting. I can use this as a simple, yes, something's not working, tell me it's not working. But if I know what my critical flows are, I can set all of these up beforehand and just say, hey, let's have these run every day. Every morning at 3 a.m., tell me all of my paths and tell me if they're passed or failed. Something changes, I can have that alert someone. I can be a little more proactive so I'm not waiting for an application or a user to scream that my application is not working. Okay, so this is the results that I've gotten from this network analysis path. So it tells me this point in time, exactly when the start is. It tells me the actual thing succeeded, but oops, network path found false. So there's no path here. Something didn't work. Why not? So this is basically what I had before. My pings don't work, my trace routes don't work, my application doesn't work. That's all I know. So it gives me an explanation. It tells me exactly why it didn't work. So it tells me, okay, well, between the reason this path that you did from source to destination doesn't work is I have an ENI SG rules mismatch. So basically, I've got a security group that is blocking this particular flow. So I know exactly what the issue is. I've got this security group attached to this ENI that is not allowing this traffic that I want it to go to, HTTPS, to be allowed in. So I can hone in on exactly where it happens to be. Now, of course, I have a full visual view of this as well that tells me really detailed information of exactly how it goes from my source to my destination. And since it tells me the exact security group that's blocking, I can look at my security group and see exactly where the issue happens to be and know that, hey, this line is missing on this security group. I need to allow HTTPS in from the source ENI to allow that in. Now that I correct that, now the network path found is true. So this is where that becomes useful, is if I run this iteratively, I can always see whether there's a true or false from any one of the APIs. Now this is exactly what Amazon Q does for you today. If you were to pop open Q and say, tell me what the path is between these two ENIs, it runs VPC Reachability Analyzer for you in the back end for that. So this is exactly the same tool for that, just happens to be a front end for it. So now that works. I have proven that the path is there. I didn't have to set up synthetic transactions. And if this was something new, I can definitively say, yes, your new application that's coming on, whatever it is, definitely works within the environment because I've mathematically proven from end to end. And I don't have to worry about, is the network the problem? And you can see here on the GUI, it shows up as reachable. So like I said, not just for troubleshooting, a point-in-time analysis, proactive. I use these for, like, I have some Lambdas set up that run these whenever I need to as a pre and post change check. So whenever somebody is making some sort of change, modifying a transit gateway, modifying some routes, whatever, I have this as part of my pipeline. So it's going to execute and run this VPC Reachability Analyzer before I make my change, do whatever change I'm going to do, runs it right afterwards. And if I had a pass before and a fail after I did my check, I know that I did something wrong. And I'm not looking at, okay, did I make my config right? I'm looking at the intent. I'm looking at, my intent is the simplest thing, source, dest, protocol. Does that work or does that all? You can also do this as a CI/CD. I have one customer that's using this in their ServiceNow workflow. ServiceNow is, does their ticketing system or their change management system. When they put a change management, it executes the pre-change. The engineer does whatever change they need to do inside the network environment. After their change, it clicks finish, and then it gives a pass-fail result. The engineer can close out their window, and they can have the surety to know they've never made a change, and they will never exit a change with a broken network. So these kind of critical application flows, let you get this full end-to-end. So a joke that we use in networking is called mean time to innocence. So if you've ever heard MTTR, mean time to repair, mean time to innocence is, from a network engineer, how long does it take for the network to say the network is not a problem and to definitively prove it? This tool gives me that. This gives me the ability to say mathematically that there is a good end-to-end flow, and I know for sure that it happens. And the network is absolutely not the problem in my environment. So wrapping it up a little bit, you do have tools. I see very few people use these kind of tools. I'm glad that they're in queue right now, that you can use this to ask questions to, but the tools have been there for quite some time to help you do troubleshooting and analysis of the environment. You can do this even if you are purely cloud native, you have some sort of on-prem connectivity. You can use this kind to help you figure out what the path is, not just within AWS, but out to my hybrid cloud, and even using other middle boxes. Most people say, okay, well, I've got to be all AWS native because I need those tools. If I have a third-party firewall, third-party SD-WAN, that's not going to work for this. This will work for this. Take the time to build your map. It doesn't take long at all. I showed you kind of the API version of it, but creating that map is essential because it's an easy way to show people that aren't familiar with your environment, hey, here's what it looks like, not from an application. Anyone can pull up a draw.io to show the application flow. This is going to show you the network flow. So the network guy that's wondering what the flow is will easily be able to figure out what that is. Don't rely on those flow logs. They're, like I said, in networking, people used to rely on sniffers all the time. Lots of money was made out of selling packet brokers and sniffers. They're still around, and it's always kind of the lowest common denominator. Now, they're still useful for actual packet level troubleshooting, but if you're just trying to use it to figure out why the flow doesn't work, it's not going to help you as much because if the flow's not working, there's not going to be any flow data in there because, well, the transaction's not there. You're never going to be able to see it. So think about building this a little more proactively. So I've done a lot about troubleshooting. Troubleshooting is a super useful way to use this, but think about making this proactive to make your life a lot easier. What I mean by that is by putting this in pipelines, be able to say, whenever I do a change, make sure that I run pre and post change checks. It really astonishes me how few engineers, especially network engineers, have these kind of pre and post change checks on networking. Sorry to say, in networking, things like the concept of unit tests really don't exist very much. We don't use that very much, and not because that the tools haven't been there, it's just not kind of part of our DNA. But the tools are there. We really got to start using them more. So I want to really implore that when you're trying to do network path analysis, troubleshooting, or even just network creation, use these kind of tools. And of course, like I said, Q already has this functionality, so use that as well. But any other things you can pull into that you want to, because this is still a lot of data. If you have thousands of applications, those can be a lot of different checks.